Hello, this is Mario from ODEON. In this video, we will explain how to calculate Speech Transmission Index in ODEON. Speech Transmission Index, or STI for short, is a parameter that measures speech intelligibility. That is, how easy it is to understand speech in a certain room. To calculate STI, you need to know the room's average background noise and define appropriate sources. First, let's talk about the background noise. These values should include sources such as air conditioning, machinery, etc. If you have these values, you can enter them in the room setup. Specifically, you need to go to the Air Conditions STI Parameters Model Check tab. And you enter the values in these fields. You can either enter them manually or paste them from the Windows clipboard with this button. If copy-pasting them, the copied values can be separated by any number of spaces or tabs. They can also be copied from a spreadsheet. Keep in mind that only the octave bands from 125 Hz to 8 kHz are used for STI calculations, which is in agreement with current standards. Therefore, you do not need to enter a value for the 63 Hz octave band. You still need 8 values to use the paste function. So if you do not have an actual value for the 63 Hz octave band, you can just enter a dummy value when you copy. If you do not have the background noise values, you have a few alternative options. One of them is to select and apply a standard NC curve from this drop-down menu. After you select it, click on Apply NC Curve. You can adjust the curve by adding or subtracting values on all octave bands with these buttons. Another option is to simulate the average background noise in your model. To do this, you will first need to define sources that represent the noise sources in the real room. Again, this would be machinery and the like, not human speakers. Then, in ODEON Industrial, Auditorium, and Combined, you can calculate a grid response. We explain how to define and calculate grid responses in another video. Then, go to the Fractals and Average tab. While in this tab, go to the Context-Sensitive menu and click on Assign Average SPL to Background Noise in Room Setup. The averages of SPL across all receivers will automatically be added to the background noise fields. In all editions, including ODEON Basics, you can also calculate a multi-point response with receivers scattered across the room. In the Energy Parameters tab, scroll down to the Statistics for SPL. You can click here to jump to the statistics for frequency parameters. Here, you can copy the average values. However, ODEON will also copy the name column. First, paste elsewhere. And copy again without the word average. Then, paste the values in the room setup with the button we mentioned earlier. Next, let's talk about defining sources. In this video, we will mainly explain STI for a non-amplified human speaker. If you need to calculate STI with a loudspeaker system, such as for reinforced speech or a PA system, there are some additional factors to take into consideration. We explain those in more detail in our application note for calculation of STI, which you will find on our website odeon.dk. Learn, Application Notes, Calculation of speech transmission index in rooms. For a non-amplified human speaker, you will need to select an appropriate directivity file, and there are two main scenarios. The first is a talker that's mainly facing one general direction, for example, a lecturer in an auditorium. For this type of case, you should select one of the BB93 directivity files. Here, you have a choice of two vocal efforts, normal and raised. These directivity files will have both the appropriate directivity and the appropriate spectrum. The second scenario is that of open-plan offices. Here, it is expected that people will talk in various directions. Therefore, directional radiation is not representative. Here, you instead use this directivity file, ISO 3382-3 Omni. This has the power spectrum of speech over an omnidirectional radiation pattern. For the calculation of a non-amplified human speaker, only one speech source should be active. For a PA system, you should have all loudspeakers active simultaneously. And for reinforced speech, you can combine the loudspeaker sources with a single human speaker source. Also remember that in ODEON, auditorium, and combined, you can calculate haze effect delays and levels for loudspeaker systems, which we explain in a different video. When looking at results, you may see various versions of STI. The ones supported by current standards are STI female and STI male, which take into account differences in the spectrum of speech for each gender. And of these two, STI male is prioritized. The reason for this is that since male speech has more power in the low frequencies, and low frequencies tend to be more problematic in room acoustics, then STI male represents the worst case scenario out of the two. So you should mainly look at STI male for safety. If active, you may also see a parameter just plainly called STI. This is actually an obsolete parameter from before the implementation of the gendered STI parameters. STI male and STI female include other psychoacoustic effects that the plain STI does not. In current ODEON versions, this parameter is hidden by default. Although ODEON can calculate STIPA and RASTI, these are also not relevant for simulations. This is because they are approximations using a smaller number of carrier and modulator frequencies, which was meant to simplify real measurements. But with simulations, it is easy to calculate all the original carrier and modulator frequencies. Also, STIPA is only applied as a direct method, while simulations use the indirect method. You can enable and disable parameters in the room acoustics parameter list, which we explain in a different video. If you calculate a grid response, STI will be shown as a contour plot by default, with each color representing the 5 qualities of speech intelligibility going from bad to excellent. Again, to dive deeper into calculation of STI, especially involving loudspeaker systems, please refer to our application note. With that, we conclude this tutorial, and we hope you have found it useful. Good luck!